There are a couple of ways to distribute heating and cooling from the generating plant to the conditioned space. Air, water, and refrigerant are the common transmission media, and each have costs and benefits. Ducted systems use air to transmit heating and cooling. They are very simple and reliable. The only moving part in most systems is the blower fan, which does not have to deal with extreme temperature fluctuations, the corrosive effects of water, or any of the flakes of rust found in boiler or refrigerant systems. The air is filtered by default, but thin filters or lack of regular filter changes can lead to cracked heat exchangers or clogged A coils, resulting in a system failure. These failures can be more dangerous than failures in other systems because a failed heat exchanger in a ducted system can introduce carbon monoxide directly into the conditioned space. Ducted systems offer a large number of optional add-ons that can save you energy, increase comfort, and increase indoor air quality. Duct dampers offer you the ability to customize the temperature in individual rooms to a higher degree. Economizers allow you to draw in outside air to cool the building on cool spring or autumn nights. Make-up air units allow you to balance air leaving through vents or combustion appliances while recovering some energy. And ducted dehumidifiers allow you to keep an entire conditioned space mold-free. Ducted systems allow for a lot of air filtration to the whole conditioned space without a lot of noise. The drawback is that ducts are large and air can't travel long distances without rapid pressure fall off. So some square feet have to be made available in the living space or close to the living space for the heating and cooling equipment. I see the HVAC industry in the US shifting a lot towards forced air systems and away from hydronics or steam, possibly because ducting has been cheaper to install than pipes, and because hydronic cooling equipment is not readily available. The dominance of forced air systems is probably for the best because of their low maintenance costs and a positive impact on indoor air quality. Hydronic systems use water as a transmission media. Water is cheap, readily available, has high thermal conductivity, and high specific heat. It has a 100-year history in the heating industry, and that has made parts cheap and readily available and fairly interchangeable. Heated or cooled water can be transmitted long distances in tight spaces, enabling heating or cooling equipment to be conveniently located on roofs, in boiler rooms, or in district heating plants. People also really enjoy the feeling of warm floors and radiative heat that are hard to achieve in other systems without dumping a lot of fuel. The primary drawback of water is its corrosiveness, leading hydronic pumps, pipes, and heat exchangers to have a lower life expectancy than blowers, ducts, and forced air heat exchangers. Hydronic pipes can burst after freezing, and they fail less safely than ducts. Hydronic water can be run through fan coil units, cabinet heater units, and other emitters that resemble forced air systems, but these units typically don't have filters because of their low power fans. It's possible to have the air filtration benefits of forced air in a hydronic system using high power fan coil units, but you'd be paying to move the heat twice, once with pumps and then again with blowers. The tremendous efficiency of district heating plants may make the math work out, but district heating systems are more fragile than distributed systems because a single rusty pump or poorly planned excavation can freeze and flood an entire city block. Hydronic heating remains very dominant in Europe, largely because of the retrofit market. If I could have warm floors, I'd probably keep my indoor air temperature lower in the winter. Split HVAC systems use heated and cooled refrigerant from outside heat exchangers to inside heat exchangers using refrigerant. The refrigerant, the piping, and the labor add up very quickly for long runs of refrigerant piping. So people rarely make runs of refrigerant lines longer than 50 feet in residential applications. When long refrigerant lines are used, additional components are often required, like sumps and pumps for oil, traps and accumulators for refrigerant, and specialty pipe insulation. Industrial process applications